Lesson 78 is particle motion. You'll notice it's particle motion 1, which means this is intro 1. You will see particle motion 2 and maybe even particle motion 3. I don't remember exactly. Okay. Now, some of this you're already familiar with because you guys are already familiar with the idea of position, velocity, and acceleration. Okay, we've talked about those connections, so we'll be reviewing those today. We have talked more probably about the fact that if you start with position, the derivative of the position function is, what's the derivative of position?
Velocity.
Velocity. And the derivative of velocity is acceleration.
Bless you.
We get to go more the other way. You all right, Cassidy? You're looking a little surprised and attacked there. Okay, so as we look at example 1, the particle moves along the x-axis according to the acceleration function a of t equals 3t. The velocity when t equals 0 is negative 10, and the position when t equals 0 is 6. Find the equation that describes the position of the object as a function of time. What is the position when t equals 2? Okay, so our main goal is going to be find the equation that describes the position of the function as an object of time. So, find the position function. What are we given to begin with? Okay. We are given acceleration. A of t equals 3t. What can we find from acceleration? Velocity. How do we find velocity? Okay, normally we'd take the derivative to get to acceleration, so to go backwards, we're going to be doing the reverse. So, v of t, velocity, is the integral of 3t dt. So, what is the integral of 3t? Okay, add 1 to the power, divide by a new power, right? So, 3/2 t squared. Officially, because it's an integral, we officially need to put on a plus c. Okay, now, because this one, so we need to find out that plus c before we can continue. In this case, it is given. I want to show you how to find it, though, because it's not always just given. Okay. What did they tell me? So we already started with a of t equals 3t. What did they tell me about velocity? Okay. So what they're saying here is that v of 0 is equal to negative 10. At time 0, my velocity equals negative 10. Agreed? So we can use that to find what c is. And again, because it's time 0, yes, c is going to be this negative 10. But that's the idea of how we can go about this. That if v of 0, that means you put 0 in for t. So 3/2 times 0 squared plus c. And my equation has to equal negative 10. You end up with c equals negative 10. Okay, I show that process because if time is something other than 0, you're going to have to actually do a little bit of work to find the c. It won't just be that number given. So what is my velocity equation? 3/2 t squared minus 10. Okay, there's velocity. Now what? Another integral, because if we know velocity, my ultimate goal is to get to position. The integral of velocity is position. So for position, I'm using x of t. You sometimes see h of t, but that's more height. I'm going to use x of t. So x of t is going to be the integral of what we just did, which was the 3/2 t squared minus 10, because I'm in terms of t, excuse me, dt. So this is x of t we're working on. What is the integral of 3/2 t squared? Add 1 to the power, divide by the new power.
So that would be 3t to the third over 6. Would be 1/2
Oh.
t cubed.
Okay. And so you end up saying 3 over 6 essentially, right?
Yeah.
And 3 over 6 would reduce to 1/2. Sorry, I had to process in my mind, but yeah. The idea is you divide by the 3. Since there's already a 3 on top, you can go ahead and cancel those 3's and you're just left with 1/2. Or, as I said, you said 3/6. That would get me there also. So you guys okay if I say 1/2 t cubed? Is that 3 canceled? Minus the integral of 10 is 10t, and then don't forget, officially plus c. What are we told up above?
Position is 6 when t.
Yeah, position is 6 when t equals 0. So officially that means x of 0 is 6. Since it's times 0, yes, your c is just going to be 6. Again, though, how do you do it if it's not like that? Plug it in, right? So if I plug in 0, it's 1/2 times 0 cubed minus 10 times 0 plus c, and that equals 6. So we do end up with c equals 6. And that means my position function, which you probably already have, x of t, 1/2 t cubed minus 10t plus 6. Okay, now what did we have to do? I'm trying to remember. Find the equation that describes the position of the object as a function of time. That's right, that right there, yes? What is the position when t equals 2? Plug and chug? I'll take it.
1/2 a cubed minus 20 plus 6.
You're finding x of 2 then. So, yep, 1/2 times 2 cubed minus 10 times 2 plus 6. Half of 8 is 4. 4 minus 20 plus 6. Or my brain says 4 plus 6 is 10, and 10 minus 20 is negative 10. So this is a position. So this is negative 10 units. Where is a position of negative 10?
0 or negative 10, 0.
Think about on a number line.
Since it's on the x-axis.
Yeah, if you were thinking about on the x-axis, okay, they said negative 10, 0, or in other words, this is 10 units to the left of the origin, if we put it in words. Okay, so that is the one thing I was going to write in here, is just that what this negative 10 represents, and realize it's 10 left of the origin. Okay, so when we're talking particle motion right now, we're just moving along the x-axis, right? So negative 10 is 10 left of the origin. Questions on that example? Okay, let's try example 2. Particle moves along the x-axis such that the acceleration function is a of t equals negative 3t. Its position when t equals 3 is 20. Its velocity t equals 1 is 5. What is the position when t equals 4? Also, at what times is the particle changing directions? Got all that? Okay, where are we starting?
Acceleration.
Okay, we are given that a of t equals negative 3t. So where do I go from there?
The integral, get your velocity equation.
In order to get velocity, we're doing the integral. So v of t, velocity, is going to be the integral of negative 3t dt. What is the integral of negative 3t?
3t squared.
Okay. Just don't forget the negative. There is a negative on this one. And so negative 3/2 t squared. I forget, did Wade say it? Plus c? I can't remember if you said it or not, honestly. How do I find c? Okay. So I like what Wade said there. In order to find our c, he says plug in 1 and equal it to 5, because we're given the fact that v of 1 equals 5. So if we plug this in, it's negative 3/2 times 1 squared plus c equals 5.
What does that say? V of 1?
That says v of 1. My pen I kind of goofed and I didn't bother to fix it. There, that looks better. It's a little late now, but you know. Okay, so negative 3/2 times 1 squared is negative 3/2 plus c equals 5. And that's my point, that we don't know c, we actually have to find it, right? So we're going to...
Wait, do we not include the t squared?
That was the 1. I plugged in the 1.
Oh, you're still going to this time.
Yeah, I haven't actually found c yet. Maybe you're ahead of me and found c.
I was, and I was
Okay,
looking
sorry.
that way.
So what is c? Okay, 5. If you're adding 3/2, you're adding 1/2. So 6.5, which probably better put would be 13/2. Or as a decimal, I guess. Mixed numbers. Yeah. So what is my velocity function?
3/2 t squared plus 13.
I have 3/2 t squared plus 13/2. And now, we're going to do it again, essentially. This time my goal is to find position. So x of t is the integral of that fun function we just found. Negative 3t squared plus 13/2 dt. Integral of negative 3/2 t squared. Add 1 to the power, it's now power of 3. Divide by 3. I'm going to say the 3's cancel and we have negative 1/2 t cubed plus the integral of 13/2 is 13/2 t plus c. What were we provided up in the problem? X of 3 is going to be 20. The position at time 3 equals 20. So, negative 1/2 times 3 cubed plus 13/2 times 3 plus c equals 20. Cubed is 27 times negative 1/2. So I'm going to say negative 27/2. 13/2 times 3, about 39/2. plus c equals 20. Negative 27 halves plus 39 halves. 12 halves. Oh, I like that. 12 halves is 6. 6 plus c equals 20, and so c is 14. Oh, lovely how it works out. So, position function, x of t is negative 1/2 t cubed plus 13 halves t plus 14. And the question is, what were we asked to find? First question,
When t equals 4.
what is the position when t equals 4? So we're finding x of 4. Negative 1/2 times 4 cubed plus 13 halves times 4 plus 14. And let's see, 4 cubed, 64 times negative 1/2, negative 32. 13 halves times 4, so a factor of 2 cancels. 13 times 2 is 26, plus 14. Negative 32 plus 26 is negative 6, plus 14 is 8. And that would be 8 units. What does an answer of 8 mean in terms of position here? It's a positive 8, so that's going to mean it's going to be, 8 units right of the origin. Okay, I believe we have one more question to answer. At what times is the particle changing directions? How do we,
Set velocity equals 0.
when a particle is changing position, or changing, not position, direction, what has to happen?
Well, I guess
It has to stop, right? And so when it's stopping, that velocity is, because it stops momentarily as it turns around, right? And so that velocity is 0. So when you're asked about changing directions, you're looking for velocity, v of t, equal to 0. So we had a velocity function somewhere, right? The velocity function I had, negative 3/2 t squared plus 13/2 equals 0. Solving for t. Sorry, I momentarily confused myself. So you can subtract 13/2 or add the negative 3/2 over. So negative 3/2 t squared equals negative 13/2. If I multiply by the reciprocal, so multiply by negative 2/3. Negative 2/3 times negative 13/2. I'm going to go with,
Just multiply by 2 since it's already negative.
say what? I'm multiplying by the negative to get rid of the negative.
Oh, okay. I thought that was
No, I was since it's already negative 3/2, I'm going to multiply by negative 2/3 because I want that negative to go away also. So now I have t squared equals 13/3. How do I find t? So in an equation setting, officially this is plus or minus the square root of 13/3. Now I have to remember before you guys ask. Someone's going to ask it, aren't they? And I don't remember why. No, not the decimal. That's not what I thought.
Time.
Negative time. I just put plus or minus on time. Why? I don't remember why. Sorry, is that bad to say? I know there's a reasoning, and it's not coming to me. Okay, so, and I get it. I'm going to read you what the book says here. So it says, we must check that both values make sense as answers to this question, of course. Looking back at the problem, no restrictions are given on the domain of the acceleration function. So we can assume a of t is defined for all real values of t. This means that negative values of time are perfectly acceptable. They simply refer to times before some particular reference point in time called 0. Therefore, the particle changes directions at both t equals negative and positive square root of 13/3. Okay, so in this case, it's, as I said, before that particular reference point of time being 0. Okay, I get it. I had to look it up. That tells you right there. I forget every time what, how they rationalize that one. Because we're used to thinking, okay, it's time. We just have to give the positive response. Okay? So, beware there. Okay, one more example. A particle moves along the x-axis so that its velocity at time t is given by v of t equals 1 over t for t greater than 0. And its position is 5 when t equals 2. Find the time when the particle is 10 units to the right of the origin. Okay, so we're provided v of t equals 1 over t. We're given some position information. And in the end it says find the time when the particle is 10 units to the right of the origin. So that means we're trying to find the time when we know that position, right? So what do we have to find here? The position equation. So if we know velocity, how do we find position? Yeah, it's the integral of velocity. So we're doing the integral of 1 over t dt. What is the integral of 1 over t? I wouldn't use the word log, natural log. Okay.
Will the t go up to a second? Or is it just going to be a natural log?
Natural log. Because here's the deal. This is currently t to the negative 1. If you add 1 to the power of negative 1, negative 1 plus 1 puts me at 0. And that's always my, oh, whoops, this is a special case. That's how my brain works, at least. Is because if this is a power of negative 1, I'm not going to add 1 and get to negative 2. We're adding 1, we get to 0. Oh, we can't have a power of 0. That just means this has all disappeared. And so this is a special case. You should know the derivative of natural log of t is 1 over t. So the integral of 1 over t is natural log of t. And of course, I didn't write it on there yet. Plus c. What are we provided? The position is 5 when t equals 2. So in order to find that c, plug your information in. So natural log of 2 plus c equals 5. So what is c? 5 minus natural log of 2. Which is messy, but we're just going to leave it as that. Okay, I'm going to leave it as 5 minus natural log of 2. So that makes my position function x of t. It was already natural log of t plus c. So I'm going to say plus 5 minus natural log of 2. And now, what did they want? Find the time when the particle is, not when x equals 10. Actually, we don't even have an x in this problem, but, well, okay, wait. When, are you saying when the function equals 10? If you're saying when the function equals 10, I guess. Because x of t is my position function. So it's kind of like t is our normal x is our normal y. I'm not sure which way you meant it, so, you know.
I'm not even sure myself.
Okay, so we're trying to find time. So we're trying to find t when the particle is 10 units to the right of the origin. So that is when the position equals 10. So we're trying to find when x of t equals 10.
Is this our last part of this problem? Or going to be another part two?
No, just this.
Okay, so you know how to insert the space, because I can edit from the
No. I mean, it's going to take me several steps to do this, but it's, you know, I don't have it squished by any means, so. Okay, so my x of t is natural log of t plus 5 minus natural log of 2, and we're going to set this equation equal to 10. Okay, I'm trying to solve for t, so I'm going to get t by itself. I'm going to move my 5 over. I'm actually going to move my natural log of 2 over because it's just a number. I mean, you can plug natural log of 2 in your calculator. It's some yucky decimal. So, natural log of t, we already have 10. I'm going to subtract 5 over and add natural log of 2 over. If I do 10 minus 5 plus natural log of 2, that cleans up to be 5 plus natural log of 2. Better than it was. Okay. How do I solve for t?
Times it by e of t.
No.
e to the 5 plus ln 2 equals t.
And how do you get that?
Take your reverse ln.
Yeah. I would say left, right, middle. Okay. There's several different ways you can think about it, I guess. My brain goes to left, right, middle. Natural log is base e, right? Then invisible base e. So e, the left to the right equals the middle. So e to the 5 plus natural log of 2 equals t. At that point, depending on the situation, you could possibly leave t there, although does that really make sense as a time? Not really. So you can get a calculator answer if you want. So whatever e to the 5 plus ln t is. You know, Wade's typing in. Does he get what I have written down in my notes already?
Yeah.
Yes? Okay. Yep. So 296.8263 if you go 4 decimal places, 826 if you go 3 decimal places. Kind of a big time.
I bet you know that your numbers are done.
I do. I definitely do.
I didn't even realize till just now that we didn't do 77.
We did skip 77.
Oh.
And so why is Cassidy realizing we skipped 77?
Seems like you kept doing 74.
Okay. So notice right here. In homework tonight, when you get to homework, first of all, you're going to be doing homework in 78. Okay, 78. In 78, when you get to 4 and 5, there are going to be problems from 77 that we don't know how to do. Or that we just don't want to do. Whatever. So, we're going to replace those with 2 problems from 77. We're going to replace those with 21 and 22 from 77.
Do you ever review worksheets?
I do. I'm glad you asked.